In this video we will dive into most popular Angular interview questions and coding challenges. And actually this video is a part of my full course Angular interview questions and practical tasks, where we are solving together 56 different questions that you can get on Angular interview. And these are all tasks that I heard or asked during interviews in the last 10 years. And you can find the link to the full course in the description box below. But if you just want to see some Angular challenges, let's jump right into it. Welcome to my course about Angular interview questions, and in this course we will solve together questions which are covering 58 different topics inside Angular, and these are all questions that I got or asked during the last 5 years, and this will cover the whole knowledge of Angular. This course is fully focused on the coding tasks. This is why I highly recommend you to try and implement every single task by yourself first. After this we will implement it together, so you know which is the best variant to solve it. By the end of this course you will for sure be much better prepared for the Angular interview to get a job. Who am I? My name is Ekaterina and I am a web developer with more than 10 years of experience, as well as a professional instructor with various courses regarding different web technologies. I did my best to put all my knowledge inside this course and I want to share it with you. So welcome on board and let's get started. I just want to tell you that the first section of my course is about TypeScript and RxJS. And here you want for sure to say, okay, but I don't really care about RxJS or TypeScript, I want to prepare for my Angular interview. And the main point is that TypeScript and RxJS are two main building blocks of Angular, and you can't really know and use Angular on a good level without using both TypeScript and RxJS. Additionally to that, inside Angular section we will use a lot TypeScript and RxJS because this is how Angular intended to be used. If you are 100% sure that you know everything that is needed inside TypeScript and RxJS, then sure you can skip these two sections and just jump inside Angular. But at least I highly recommend you to look on the titles on the videos and check if you really know everything that is needed for the interviews. The most popular question that you can get about TypeScript inside Angular is why is TypeScript needed inside Angular and what is pros and cons of TypeScript. So here you need to answer that TypeScript is the most popular statically typed language which is built around JavaScript, which actually means we have exactly the same syntax like inside JavaScript, but we're adding static type into this, which actually means we're not getting errors just like inside runtime with JavaScript, we're getting them in transpilation time when we're transpiling TypeScript to JavaScript. And it is important to mention that you can't use TypeScript directly in browsers. There we can use just JavaScript. This is why we must always transpile our TypeScript code to JavaScript code. So getting transpilation errors is the most important benefit of TypeScript. Secondly, it is easier to scale our code because we are breaking less things. Typically, if you just refactor your JavaScript application, you will break something for sure, because you can see your error just in runtime, but not in transpiling time. Also, typically you will see your TypeScript error directly inside your editor, even not in your terminal, which makes development much faster. And last but not least, TypeScript helps us to define entities. If we are talking just about JavaScript, there we have just arrays and objects. We don't have anything else to define and write what we have inside our applications. Inside TypeScript we have different data types to describe what we have inside our application. For example, we can create an interface for the user, and then in every single place of our application we don't simply write an object with ID and name, but we define it as a user interface, which actually means TypeScript allows us, with the usage of typing, to define entities and work with entities across your application. And this approach is much more stable and easier to read. And if you are being asked what are cons of using TypeScript, first of all is the level of entrance. If you are simply a beginner, it is much more difficult to start with TypeScript because additionally to all JavaScript knowledge, you must learn typings and it is not an easy task. Another problem I already mentioned, we can't really execute TypeScript directly in the browser, which means we must always transpile our TypeScript code to JavaScript code, and it can take quite a lot of time if your project is really huge. You might get a question to understand if you know something regarding TypeScript interfaces. And as you can see, our question is written like so. Define a user interface with ID, string, name string, age is number, and a method getMessage that must return a string. Write a usage example of this interface. So let's try to do this now. First of all, we must define an interface, but before we will do that, you can also get a question, what is an interface in TypeScript at all? And actually this is a possibility to describe some object with data that we can reuse everywhere. And this is exactly what we need to do here. We must define a user interface, and this is a special typing that we will reuse across the whole application, and we will show if we're using this typing, it must have inside this ID, name and age of these specified types. So in order to define our user interface, typically you will write it like this. We're exporting interface, here is user interface, and this is an object. And inside we are defining first of all an ID, we know that this is a string, secondly name, it is also string, and last one is age, here we have a number. But additionally here we must define a getMessage, so let's add here getMessage, which is a method, this is by here round brackets, and here we must specify what this method returns. And as you can see in the task we are getting a string, so here we are writing just a string. So this is how you typically define an interface. And if you're asking why here we wrote a word export, this is because we want this interface to be used across the whole application and not just in this file. This is why here we're using export, so we can import it everywhere. And now we must write an example of usage of such interface. So typically somewhere inside your code you will create a variable user and you really want to be sure that it specifies our user interface. This is why here we are saying that our user must be a user interface. And after saving you can directly see here an error. Type object, and this is an empty object, is missing the following properties of type user interface. It is ID, name, age, and getMessage, which actually means now we're on the safe side and we're 100% sure that this object that we're creating here will be validated against our interface. This is why here inside we can define, for example, ID is a string. Now here we have a name, for example, user foo, then we have age, maybe 30 years old, and here getMessage, and our getMessage, as you can see, is a function which must return string. Here we should not write anything and we can simply return any string that we want, but we can make it nicer and just write here a name of our user, so this name, space is space this age. So we successfully wrote the example of our interface, and most importantly now here we can't throw any additional properties. For example, I can't write here bar, because in this case here our interface is not satisfied, and here we can't get a bar property in our user interface. Another question that you might get about TypeScript is regarding arrays. And here we have a task, how to define an array in TypeScript, show always. And actually inside TypeScript we have just two possibilities to define an array. First of all, here let's create an array, for example fruits, and we're saying that this is an array of strings. This is why here our type is string, and here we're putting brackets to say that this is an array. And now here we can define an array, like for example apple, orange, banana. So this is the first and the recommended approach to create an array. Another approach will be that instead of string array, we're saying here word array, and inside the tag we're writing the type, and in our case it is a string. And essentially this line is exactly the same like the first line. But it is different. Here we're saying that we have an array of string, but here we're saying that we're using generic type array to define the type of our array. And we will talk about generics in one of later videos, so stay tuned. And the second question that we're getting here is how to define an array of numbers and strings. And actually, in order to answer that question, you must know how to create OR inside TypeScript. And actually, if you want to define OR, typically you write something like this. You have a property foo, and the type of it is either string or number. And exactly this pipe is our number. This is why here we can set 0 and we can set here foo string and we won't get any error. Exactly the same we're getting with arrays. So here let's create an array of our values, and here we can define that we have a string or number, just like it is inside task, of array, which actually means this is what we're getting inside array. And here we're defining with brackets that this type is an array. Now here we can create our array and write here, for example, apple, then 2, then maybe orange, and 3. And as you can see, we don't have any errors because it is possible to have string and number inside an array. But if you want to show that you are a really good developer, you must mention that this is a bad practice to have different data types inside a single array of objects, because then it is much more difficult to transform this data or validate them. So inside real application, I will always question if I see code like this, string or number. It is always better to have either strings or either numbers, or maybe your user interface if you are using that. Another question that you might get is how to fix this code. And as you can see here on the bottom, we have a function where we're getting an error. Object is possibly undefined. And actually you either get such task or you just get a plain question, what is type assertion inside TypeScript? And actually here you must tell that type assertion means that we're forcing TypeScript to take another type. Or sometimes it is not forcing but just guiding TypeScript to take correct type. And we're doing that with the keyword which is called as. So let's look on our problem here. We're getting here a function getItem where inside we're getting just a single parameter item of type number or undefined. And after this, inside this function we're trying to call on this item to string. And obviously we can call to string on the number if the data type is number, but not on the undefined. This is exactly the error that we are getting. We can't call to string if our item is undefined. This is exactly what we can see here. So how we can fix that? And this is exactly where type assertion comes into play. We can simply wrap this item with round brackets and write inside as and the type that we want, for example a number. In this case here we're saying for TypeScript, okay, I am sure that this item here is a number. You don't need to check that. And now here we can call to string function without any problem because here TypeScript is sure that this is a number. But additionally to that, if you want to show that you are a really good developer, you must say that this is the bad code. Why is that? Because here we're getting an item and it can be number or undefined. This is totally fine. What is not fine is writing code inside where we simply type asserting it to number. This is bad. We must first of all check here for the undefined and do something about it. Because here we're waiting for the undefined and then we don't have a case to write it. This is why here much better code would be something like that. If we have here an item which is undefined, so not item, then we want to return, for example, null. And in other case here we simply don't need to write anything because now it will be completely valid. TypeScript understands that with this check we're getting undefined away. And now here our item will always be a number and we don't need to type assert anything. And this is the best possible solution for this case. Another question that you can get regarding TypeScript is what is a void type, and we must write an example how we will use it. And actually void type is widely used inside TypeScript. Typically we will use it just in a single case, when our function does not return anything. What does it mean? For example, here we can define a function do something, and this is just a function without arguments. And actually here we might omit anything and just write console log do something. What does it mean? Our function does not return anything. And if here we will check do something function, we can see that this function is returning void. So by default, TypeScript understands that we don't want to return anything here. But actually, I highly recommend for you to always write what you want to return back. In this case here, we must put colon and then void. And here we're defining that our function should not return anything. And this is really important because in this case here, if we will return, for example, false, then we will get a warning. Type boolean is not assignable to type void, which is correct. The main problem, if you won't write void here, but you simply return something, TypeScript will think that you really want to return something. This is why here the definition will be that doSomething function will return a boolean. And this is not what we want. We want to return here void. So with void inside TypeScript, we're defining that we don't return anything. And you could actually define a property of type void, but it doesn't really make any sense because you can't assign anything there. This is why we're not using void as a type for a variable. Another question that you might get after this is what is unknown? Write an example. And actually this is much more interesting and much more tricky, because actually not enough people are using unknown inside TypeScript. So let's look on such code. Let's define here a property vAny of type any, and here we simply assign 10. And here we are defining another property vUnknown of type unknown. And here we also assign 10. So actually we want to find out the difference between unknown and any, because they are kind of similar. So after that I want to define a new property s1 of type string, and I want to assign here vAny. And after this I want to define property s2 of type string and assign here vUnknown. So what will happen here? As you can see, we don't get any error in the first case. So here we have s1 string and we are assigning here vAny. The main point is that this variable is any, so it doesn't really matter what we will write here. It can be a number, a function, an object, an array. We won't get any TypeScript error, because just to remind you, if we're using data type any, TypeScript is completely disabled. It won't check anything. This is why here we can assign number inside string, and it doesn't make a lot of sense. What we are getting here in the second case, we are getting type unknown is not assignable to type string. What does it mean? Actually here we have the unknown property of type unknown, so we don't know the data type yet. And in this case here we assigned here a number, but we set a type unknown. And actually we want to use type unknown always instead of any. What does it mean? If we don't know what type is that, we should not write any, we should write unknown. And actually unknown data type was introduced in TypeScript 3, and I highly recommend you to use it if you are not sure what data type you have. And here is one more important point why we must stick with using unknown and not any. If I will write here console log vAny.foo, we won't get any error because our vAny is any, and we can call here whatever code and TypeScript won't say anything. But if we will try here to console log vUnknown.foo, we will get here an error because object is of type unknown, and we can't just call here something with the type unknown. And at this point here you might want to ask, okay, but how do we fix this error with unknown? And for this we must use type assertion from the previous lecture. So we must use as notation to define to what data type we want to convert our unknown. In this case here, for example, we can say the unknown as string. So we won't get any error because we're assigning here a property of type string to the string, and TypeScript doesn't say anything. In this case here, if you want to call foo, you need to convert your property unknown to something which has a property foo inside. So again, to answer the question what is unknown, it is a data type which is much better than any. Why is that? Because after we used unknown, we must specify later what exactly data type we have. If we're using any, we don't need to do anything, TypeScript is just disabled. In order to check your TypeScript knowledge, you might get a bigger task. And as you can see here, we must first of all create a user interface with ID, name and age and getMessage function which returns string, which means this is exactly what we did in the video regarding interfaces. The next point is create profile interface with name, profile URL and isActive property. And obviously name and profile URL are strings, isActive is a boolean. Then after this we must create a function which transforms user interface to profile interface. And here is a hint, the profile URL is /profile/ and here will be the name. And the last point, add optional parameter isActive, so profile must be either active or inactive and this parameter is mandatory. But here is the point, this is optional parameter, which means if it is not provided, then our profile is active. So first of all, let's start with defining our interfaces. And here I want to create an interface which is called user interface. And inside, first of all, we are defining ID, which is a string, then name is also string, age is a number. And the last one here is getMessage, which will return for us a string. After this, we must define the same interface, but for profile interface. This is why here let's define an interface which is called profile interface, and inside we have our name, which is a string, then profile URL, it is also a string, and the last one is active, which is a boolean. And as you can see here, we don't have optional fields. The last point here, add optional parameter isActive, is not interesting for us, because our profile must be active if the parameter is not provided. So with that we implemented 2 points here. The third point here is to create a function which transforms user interface to profile interface. So here let's define a function with the name transform user to profile, for example, and here we're getting just a single argument which is a user. And this is actually our user interface that we defined, and here we must specify what we're getting back, and in our case it will be profile interface. And this is an arrow function where inside we want to map all fields to the needed fields. In our case here we can simply return what we need back for our profile interface. First of all, it is a name and we're taking it from user.name. Then we must create profile URL. Here was a hint, the string must look like this. It is /profiles and here is going name, which actually means here we can write /profiles/ and here will be our user.name. And the last thing here is isActive property. But the main point is we didn't provide it to this function. And as you can see here, we must create an optional parameter inside our function. And by default, this parameter must be set to true. This is why here we can write as a second argument our isActive property. And actually it must be Boolean type, and by default we can set it to true. In this case here we will directly assign isActive as true by default. And if we are providing it inside our function, then here it will be overwritten. But actually at this moment you might say, okay, but we didn't write that we have an optional parameter. And you might remember that inside Typescript, to make parameters optional, we write here a question mark. But if we will try to write it like this, we will get an error. Parameter can't have question mark and initializer. What does it mean? Here we are saying that we have a default value which is true, which actually means only when we will remove this default value, then we can write here a question mark. And then this will be either undefined if it is optional, or we will provide it inside. But this is not the best approach for us because we want to set it by default in true. This is why actually this line is the optional parameter, because we don't need to provide inside our function isActive always. We can try to write it now. For example, I'm calling transform user to profile, and as you can see here, we must provide a user and isActive property. And if I will just provide here a correct user like ID, then name, for example, full, then age 30, and getMessage function, which must return here full, as you can see, we're not getting an error because our second parameter isActive is optional. And you can see it from the definition. But if we need to, we can provide here a second parameter, and in our case, we just need to provide a false because it is true by default. You might also get a question like this. what is tsconfig JSON and what does these options do. And as you can see here on the bottom are the options that you can typically see inside tsconfig JSON file. So we're using tsconfig JSON to configure Typescript compiler, which actually means if you need to configure, for example, in what ECMAScript version your Typescript transpiles JavaScript, this is exactly the place to change your configuration. If you also want to change some settings of Typescript, like for example make it stricter or allow different rules, you also need to use tsconfig JSON. And as you can see here are most popular properties that you can see inside tsconfig. So first of all, inside tsconfig we have a property which is called compiler options, and this is what we typically want to change. First of all is target. So what is target? This is to what JavaScript version we will transpile our Typescript, and here we have a configuration of ECMAScript 5. The next thing is a module, and here we're specifying if we want to use CommonJS modules, like you can see here, or ECMAScript 6 modules. In CommonJS we have require and exports, and inside ECMAScript 6 modules we have imports and exports. The configuration module resolution is setting how our modules will be resolved, and typically you will write here node. And for example, this is one of the rules how you can configure your Typescript to highlight some errors. And as you can see here, we have a setting no implicit any, and it is set to true. What does it mean? Sometimes you can write a code where you didn't define an any as a data type, but actually it is there by default because of how you wrote your code. And this option tells you when you have such case, which actually means this option is good because you will know that in this specific case you are getting here any, so you either need to specify it by hand or change your code. And the last thing that I want to mention is where tsconfig JSON is lying inside typical Angular application. And here I have an Angular project, and in the root of it we have tsconfig JSON and tsconfig app JSON. And actually this tsconfig JSON is the main one, and this tsconfig app JSON is extending this tsconfig. This is exactly what you can see here. And this is the typical configuration that you will see inside Angular. For example, you have compile and save, and here inside compiler options we have lots of different options. One more important point to know: if you want to override tsconfig for some child directory, you can just create in that child directory tsconfig JSON file, and then it will override tsconfig in the root. Another Typescript question that you might get is what is Elvis operator, and can we write please a common use of it? And actually, in order to demonstrate it better, I would like to create an interface. So let's say that we're defining an interface which will be just a user interface. And for example, here we have ID, which is a string, and also a name, which is also a string. And now here we want to define a function, for example, getName. And here we're defining that we're getting a user, but we're using now here a question mark to define that we can get here undefined. And here we're defining that we're getting user interface. And back we want to get a string. Now inside here we will return user.name. And as you can see here, we're getting an error, object is possibly undefined. And this is happening because our user here can be either user interface or undefined. So the question is how we can fix this error. And this is exactly where we need to use Elvis operator. What it does, it just checks the nesting of the property without breaking the code. This code will break in the runtime, and we will get an error like cannot read name of undefined. This is the typical error of JavaScript. Inside Typescript we can put here after user a question mark, and this is exactly the Elvis operator. So here we're saying, okay, we're not sure that user is there, but we're simply trying to get a name. The point is that we will still get an error here, where getting type string or undefined is not assignable to type string. Why is that? The point is that if we have here a name, then we're getting here a string. If we don't have here a user, then this Elvis operator can't read name, and this whole construction will return for us undefined, which is totally fine because in this case here we can write or, not set. which actually means if we didn't provide here a user as an argument and we know that our user is undefined, we're trying to read here name. But as you can see, we're still getting string or undefined. This is obviously not that we want to return for get function name. This is why here we're defaulting to not set. And this is exactly the correct usage of Elvis operator. So if you have some nested properties and you're not sure that you can get them, then you simply put a question mark, and if you can't get them, you will get an undefined back. You for sure get a question like this: why any type inside Typescript is bad? And first of all, you need to remember that Typescript disables completely any checks inside language itself, which actually means if we will write here, for example, property foo, and we will write that the type here is any, and we're assigning here foo, we can simply write here something like console log foo.bar, and we won't get any errors. Why it is happening? Because Typescript does not validate anything if we have any. But the main problem is here that typically people don't want to use any at all. They are using it just to fix their Typescript problem, which actually means if the person is just a beginner, typically he will get some Typescript error that he can't understand and can't fix fast. And in this case, he will just use any to fix his problem. And this is a bad approach, because actually your Typescript application will become an application with the holes in it in every single place where you are using any, because there Typescript is simply disabled and can't help you. So actually 90% of the people are using any not because they really need it, but just to fix their problem. And this is a wrong approach. You really must take your time and fix your Typescript error in the correct way. So now the question is when you need to use any. And typically you want to use any if you don't know what data type you will get. For example, you could say that you have a function and you don't really know what will be the argument inside. Let's say here we have a function foo and we're getting here bar. And it might be that here we will get like a string, a number, an object, an array, so we can't really type it. But even in this case, we have two different possibilities, which are not any. First of all, you can use here generic, and we will talk about generics in one of the future videos. And secondly, you can use here unknown type that you already know. If we will write here not any, but unknown, then we know that we need to check inside every single type that we are getting and understand what logic we must apply for it. Which actually means the usage of any inside any application must be super limited. And it is quite easy to understand how bad Typescript application is. You can simply open a new project, maybe in your new job, and just try to find all usages of any. And if you see in the huge project like 2000 usages of any, this is not a safe project. But if you see like 5 or maybe 10 occurrences in the whole project, then this is totally fine and this project is safe. And you will for sure get a question regarding enums inside Typescript. And typically it will be like this: what is an enum? Can you write an example? And why are enums so good? So first of all, the question is what is enum and how we can create one. And actually for this we are using reserved word enum and then the name of our enum. And the typical code style to write a name of the enum is with the capital letter. This is why here let's create an enum for our statuses. This is why here let's name it status enum, and we simply create here an object. Now here inside we're creating keys and values, which actually means it is really similar to the object and not to the interface. And typically we're naming our keys uppercase, but it doesn't really matter, this is just a code style. So here we can create an active key, but here we don't put a colon but equal sign, and here we're assigning active, then comma, and we have a next status enum, which is possible. And here we're writing draft, and this is a draft, and the last one here is archived, and the value is archived. So what is enum at all and why it is so powerful? First of all, as you can see, it is looking kind of similar to the interface, but actually it is not. Interface is simply a representation of the object. We just define inside all keys and the types of our values. But here it is different. We're essentially defining here constants that we can reuse everywhere, which are related to our statuses. So essentially we could write here just const and use it everywhere. The main difference is that inside TypeScript we can use enum not just like a type, but as a value. Just remember this is really important, which actually means if we're creating our function, for example isActive, and we're providing inside the status, we can use here an enum as a type. So we're writing here status enum. And back we want to get a boolean because this is check for isActive. But inside we can use our enum as a value, and this is super powerful. This is exactly why enum is so good. So here I can return not state but status, and here we want to return our status equals status enum dot, and here we have a nice autocomplete for active, which actually means here we're comparing the status that we got as an argument with the status enum dot active. So first of all, we know that we grouped all our possible statuses in just a single enum. And now in the whole application, we're not using just strings to compare, so we're not writing here something like active, where we can make a typo. We really use here an enum, and it is everywhere the same, which actually means we can change this word active here, and it will be updated in the whole application. Secondly, we're using here enum as a data type, but also as a value. And now let's see if we can use isActive and just pass a string inside. So here I want to call isActive function, and as you can see we must provide inside status enum, but actually this is a string, and people might think, okay, I can throw here active as a status, but as you can see we can't because the argument of type active, and actually this is a string, is not assignable to the parameter of type status enum, which actually means in the whole application we can't write code like this. We will write it like status enum dot, and here will be active. And this is really the correct code because we are not comparing some random strings inside our application. But at this moment you want for sure to say that you are getting your data from the API, and then there you are getting a string. And what you need to do in order to use your data as a string with our function isActive. And let's say that you have a user with active property, which actually means you will write here user.status maybe. But actually your status is a string. In this case you can write here as, and you already know what as is, and here we're writing that this is our status enum. This is totally fine, but only if you are getting this data as a string and not using it as a string across your whole application. You might also get a question like this: how you can create a custom type inside TypeScript, and when does it make sense? So the first question, how to create a custom type inside TypeScript at all. And for this we can use a reserved word which is called type. And we can name it whatever we want, for example foo, and typically we are writing it with capital letter. And here we just assign some data type, for example a string. What it does, it creates a new type foo, which we can use, and it is a type string, which actually means here I can create a property foo of type foo, and here I can simply assign word foo, which actually means this code is exactly the same like assigning here a string. This is why a lot of beginners are wondering, why do we need a custom type at all if we simply take a type that already exists? It doesn't make any sense to have here a type foo if we can just write here a string. But here are two cases when you need custom types. And first of all is readability. This is the same if we are comparing just plain JavaScript objects and interfaces. We're using interfaces to describe our entities. So we're not working with the object of ID, name and age, we're working with user interface. This is much clearer for us. If in the whole application we have a lot of strings, then it becomes unreadable and unsupportable. If we will define here, for example, a type ID, and now here we create a new property, or we use a property inside the interface of type ID, it is much more clearer. We know, okay, we are talking about type ID and not just some random string, which actually means the first case to create custom types is to bring clarity to your code. The second case is to write custom type if you can't use interface. And essentially you're using interfaces much more than types, because inside type you can assign just something like an interface or maybe another data type. Inside interfaces you can pack lots of stuff and reuse interface as an entity, which actually means we're using interfaces more often. But sometimes we can't use interfaces. Let's create here our favorite interface, which will be a user interface. And let's say that we have here an ID, which is a string, then name, which is a string, surname, which is a string, and last is age, which is a number. But now we just want an interface where inside we will have name and surname. And we could create a completely new interface just with these two fields. But actually there is another way to do that with usage of omit and pick. And there are two different things inside Typescript which allow you to get some properties from the interface or remove some properties from the interface. Which actually means here we can create a new type and we can name it user, full name type. And here we will use pick inside the tag, first of all the interface, in our case this is user interface, comma, and here as a string we must provide what we want to pick. In our case, for example, we might want to pick just a name, which actually means our user full name will have an object with a single field name. And actually this code you can't write with the interface, because you can extend interface, but you can't really create an interface and cut some fields from it. We're using for this pick, and this converts our interface to the type. If we need to pick here several things, we can use a pipe. So here will be pipe and maybe surname. In this case here, as you can see in our data type, we're getting name and surname. And in the same way we can use omit, so we can create here a new type, user, post maybe, and here we want to call omit function, provide inside our user interface, and as a second argument we want to remove ID. In this case, inside our user post, we will have an object with name, surname, and age, which actually means we either use custom types to bring clarity to our code, or we use them as a result of some type change, like for example pick or omit. The most popular question that you might get regarding TypeScript is obviously generics, just because it is a more difficult topic that is used a lot. And actually the question typically will be what are generics inside TypeScript, and can you please write an example how we're using them? And actually generics is a difficult topic, but just to start we can describe it in an easy way. If you see in the code something like array, then open and close tag, and we're providing inside a string, actually this is a usage of generic. Why is that? Because essentially we're not just using here a data type, we're using here a construction with open and close tag, where inside we're providing a data type that we want to see. Which actually means array is a generic type where inside we can provide what exactly type we need. And it makes a lot of sense because here we're defining, okay, we have an array of strings. And typically you will write it like this. So we have an array and this is string array, and here we can write, for example, foo. Also inside Angular you can see a lot the usage of observable, and there we're writing observable, then open close tag, and inside we're providing, for example, a string, which actually means we're working with the observable where inside we have a value string. And here we can provide any value that we need. For example, here will be the data type number, which means we're getting a number inside our observable. So why generics are so valuable? They allow us not to duplicate code a lot, but just create something reusable which can accept the different data type. Just imagine the previous example without generics. We're defining here array of strings, then in the next case we're defining array of numbers, then we have array of some interface. It is not reusable. In this case with generics we can reuse just a single thing for any data type. If we are talking about functions, it is looking like this. For example, we can write here get item, and we are providing here before we are calling this function something inside. For example, this is a string, and here we can provide a foo. And typically it will mean this is the data type that we need to use inside this function. For example, the first argument in this getItem function can be any data type. and we could write any there, but it is not that valuable. This is why we can create a generic function where inside we will set the data type that we can then reuse later in this function. So we're using generics to create reusable code. And now let's write a simple example to understand how generics are working. Let's create first of all a function addId, and here we're getting an object. And actually I will intentionally not provide here a data type. Now inside what we want to do, first of all, we want to generate a unique ID. This is why here I will call mathRandom and just do toString of 16. This will generate kind of unique ID. Now here I want to return the new object where we're spreading object that we got, and here we simply add an ID. What is the purpose of this function? This function simply gets object, but as you can see it is any, because we didn't provide here a data type and it is not intentionally any. Here we're generating our ID and now we're spreading the whole object and we're adding here ID. Essentially, inside this function, we don't care what data type we're providing inside. For us, it is just important that this is an object. And if it is an object, then we can spread it and add here an ID. And the typical usage of this function will be like this. For example, we're defining the user, which is an object, with name, let's say Jack. And now here we want to get our result by using our addId function, where inside we're providing a user. And actually this code will work, but as you can see, first of all, our result is any, because we have no idea what is user and we don't know what we're getting back. This is why our addId function is getting object which is any and returns any. This is not a best approach. We could leverage here generics in order to have stricter typing. To do that, we can just write here before our round brackets, inside open and close tag, some big letter, and typically you are writing T. Now here, instead of just object, we can write object then colon T. What does this construction mean? This is the definition of generic for our function, which means our function now is generic function. And here we're saying, okay, in our function we must provide a data type of the object, and actually we're using this T as a data type for the value that we're providing as a first argument. And essentially you can use this T anywhere inside the function, but in this specific function we want to use it here. Now let's have a look on our data types. I'm checking here data types and it looks completely different. Why is that? Because now we don't have any at all. So here we have addId function, and as you can see, this is our generic. So inside T we are providing an object with name string. Typescript understands this code, and Typescript sees that we provided user as a first argument here. And actually here on the top, we know that this T that we're providing here is our generic T that we provided inside the function, which actually means Typescript understands the data type for this object because this is this object. And as you can see here, we're providing inside our addId function as a T, this object with name string. And this is what you can see here. We have an obj variable of object with name string. And this is what we're getting back. We're getting exactly the same object with name string and an object with ID string. This is how Typescript shows us the merge of this object and this ID. And this is what we're getting as a result. Inside we have an object of the name, which is merged with the object of ID, which actually means now it is correctly typed, and we can write here result, and now result dot brings us two properties, name and ID, which means our Typescript here is completely valid just because we used here a generic. But we're writing code like this when Typescript can read it by default. Sometimes it is not like this, and in this case we must provide a data type here inside. For example, we can provide here an object with name string. Why we are writing it like this? Because essentially inside we're providing a user which is an object with name string. This is exactly what we specified here. This is the data type which we need to provide for our function. And if we will provide here, for example, foo string, then we will get an error, because actually we're getting type mismatch and property foo is missing inside our user object with name string. So generics allow us to specify what data type we're providing inside. And this was the end of the first chapter. If you are interested in learning Angular interview questions even further, make sure to check the link in the description box below.